Hi everyone, in this video we're working through the problems in our discrete final exam review. First problems have to do with graph theory. So here's the first problem. Describe how many vertices and how many edges the graph has. The graph has 1, 2, 3, 4 vertices and 1, 2, 3, 4 edges. Next problem. Determine whether the graphs are isomorphic. If they are, illustrate the isomorphism. All right, so for this problem, if I were to take this point right here and take it outside, because I can move these vertices, then I would have a triangle followed by a square or a quadrilateral. And that's the same that we have on this graph, a triangle followed by a four-sided figure. So both graphs do have the same structure and the same relations. So that means that yes, they are isomorphic. Decide if a Euler circuit exists for the graph. To do this, we will count the degree of each of these vertices. So for this vertex here, it has two edges coming from it, so it has degree 2. This vertex has degree 4, degree 2, and degree 4. So because they're all even, that means that yes, a Euler circuit exists for the graph. Compared to this particular vertex here, where you have an odd number, there's a degree of 3. If there's a single one with an odd number, then no, a Euler circuit does not exist. Remembering that a Euler circuit would be a path that would hit each of the edges exactly once and return back to wherever it started. So there's that Euler circuit. In this problem, we're determining if the path that's given is a Hamilton circuit. A Hamilton circuit would be a circuit, so it would begin and end at the same place, at the same vertex, plus it would have to hit each vertex exactly once, compared to a Euler circuit that hits every edge exactly once. So let's try this. We're going to go A to D, and then to C, to B, to E, and then to A. And we can take this path over here to A. So that does in fact hit every vertex and returns to where it starts. So yes, that's a Hamilton circuit. Looking at the next example, is this a Hamilton circuit? We're going to go F to B, to D, to A, to E, to C. So while that does hit all of the vertices, it's not a Hamilton circuit because it doesn't return back to the F. So this one is no, whereas this example is yes. Okay, next problem. For the graph below, use the nearest neighbor algorithm to find the approximate minimum Hamilton circuit and its weight starting at the indicated vertex, so starting at A. For the graph below, use the nearest neighbor algorithm to find an approximate minimum Hamilton circuit and its weight starting at the indicated vertex. So here we're starting at A. Okay, so to do this, we're going to start at A and we're going to find and look at the edges that are touching A. So we could go possibly 3 from A to C, which is actually this 7 right here. or 5. So we're going to go A to E, which is 3. That's the smallest of the 3 options. Or I didn't even see this 8 right here, going A to D. But the smallest path is A to E, which is 3. Now the options are 2 to B, 6 to C, or 9 to D. So we'll go 2 to B. That's the smallest number. Now the options are 5 to A, but we can't go back to A yet because we have to hit all the vertices. So 4 to C or 15 to D. So we'll go 4 to C. And then we have to go to D still. And we have to go back to A. So altogether that would be a weight of 3 from A to E. So 3 here, then plus 2, plus 4, plus 11, plus 8. So adding up those numbers, that's 5, 9, 28. So using the nearest neighbor algorithm, the weight would be 28. Determine whether the graph is a tree. The reason why it's not a tree is because it has a circuit. A tree would have no circuits and would be connected. Determining if number 9 is a tree, yes. This is a tree because there's no circuits in it and it is connected. Number 10, find all the spanning trees in the graph. Okay, so we could either remove this edge, in which case the graph would look like this. That would be 1. We could remove this edge, in which case it would be this 3-pronged graph. Or we could remove this edge, in which case it would look like that. So there's the 3 spanning trees. Spanning trees that touch it spans to all the vertices, and we have to remove one of the edges so that we don't have a circuit. Number 11, find the minimum spanning tree for the graph. Okay, so to do this problem, then we want to first find the smallest edge on it, which for this case, I'm scanning the numbers, looks like it's 9. And then the next smallest edge is 10. Now we cannot do 11 because then we would get a circuit. We're looking for a spanning tree. So the next lowest number is 13. Next lowest number is 15. And then the next lowest number is 16. So there's the minimum spanning tree of the graph. Number 12, using the 36 possibilities found in the product table for rolling 2 dice, list and count the outcomes for which the sum for both dice is equal to 8. So we have to roll 2 dice and get 8. So you cannot roll a 1 and a 7 because dice go 1 through 6. But you could roll a 2 and a 6. That would be one possibility. You could roll a 3 and a 5. You could roll a 4 and a 4. You could roll a 5 and a 3. Or a 6 and a 2. Notice 2 and 6 and 6 and 2 are different because I got a 2 on the first die, a 6 on the second die compared to a 6 on the first die and a 2 on the second die. So that's a total of 1, 2, 3, 4, 5 possibilities. The next problem, we have 5 factorial divided by 7 factorial. So simplifying this, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So all of these factors are going to cancel. We're just going to have 1 over 7 times 6. So that's 1 over 42. Number 14, a shoe store carries one brand of shoe in 3 different styles, 4 sizes, and 5 colors. How many different shoes are available of this one brand? Well, because each of these properties is independent of each other, then we could multiply to find the number of ways. So that's 3 times 4 times 5, which is 60. So 60 ways to have a pair of shoes. Next problem is 8 pick 2. So this is for permutations. And you can use a calculator for this, or you could use the formula n factorial over n minus r factorial, which will be where this is n and this is r. So that would be 8 factorial over 8 minus 2 is 6 factorial, which ends up being 8 times 7. So that's 56. Next problem, 14 choose 8. You could use a calculator for this one, or using the formula, it would be n factorial over n minus r factorial. We're just dividing by that additional factor of r factorial, where this is n and this is r. So 14 factorial divided by 14 minus 8 is 6 factorial, 8 factorial. So figuring out that, so 14 divided by 8, 8 through 1 would cancel, so it would be 14 times 13 times 12 times 11 times 10 times 9 divided by these 6 times 5 times 4 times 3 times 2 times 1. So that will equal, canceling, we'll get 7 times 13 times 11 times 3 is 3003. Of course, you could also press the PRB button to use your calculator to calculate either permutations or combinations. A student is told to work any 6 out of 10 questions on an exam. In how many different ways can he complete the exam? The correctness of his answers has no bearing. So just how many ways is it possible to fill out 6 out of 10 questions on an exam? Well, here the order would matter because for a particular question it would be different if you answered A for one compared to A for a different one. So it's going to be permutations instead of combinations where the order does not matter. So it'll be 10 pick 6. So getting that will end up being 10 times 9 times 8 times 7, which is 5,040 ways. Next question, a die is rolled twice. List the ways of getting the following result. The sum of the numbers showing is 5. So you could roll a 1 and a 4. You could roll a 2 and a 3. You could roll a 3 and a 2, or a 4 and a 1. So for rolling a 5, there would be 4 ways. Next question. Use a tree diagram showing all possible results when 4 fair coins are tossed. Then list the ways of getting exactly 2 tails. Bring out this tree diagram. The first choice could be, the first flip could be heads or tails. And then the next flip could be heads or tails. The next flip could be heads or tails. And the last flip could be heads or tails. Okay, and so that's going to be 4 flips. That would be all 4 heads. Then filling out the rest of this, you could have heads or tails here. Okay, so that would be the ways. I'm using a tree diagram of flipping 4 coins. Now we're looking for exactly 2 tails. So one path would be 2 heads followed by 2 tails. You could have a head, a tail, and then a second tail. So there's a second tail. You could have a head, tail, tail, head. There would be a third route. You could have a tail, head, head, tail. That'd be a 4th route. A 5th route, you can get a tail, tail, head, head. A 6th route, you could get a tail, head, tail, head. And now looking symmetrically at it, you see that there's 3 paths per half of the graph. So there's 6 ways. Next question, choose the one alternative that best completes the statement about Pascal's triangle. So Pascal's triangle, just reviewing, goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So each number here, you would add the 2 prior ones to get that. To get this 3, you would add the 2 and the 1 that are above it. So each entry, except for the first, is the sum of the 2 nearest entries in the row above it. Okay, probability. First question, give the probability that a spinner would land on a black. So there are 1, 2, 3, 4, 5, 6 total. And of those 6, 2 are black. So it's a probability of 1/3. Next, a bag contains 4 red marbles, 3 blue marbles, and 9 green marbles. What's the probability that a marble is blue? So it's out of 4, 3, and 9. So that's out of 16 total. And there's 3 blues, so it's 3 out of 16. Next question. What are the odds in favor of spinning an A on this spinner? Okay, so odds are favorable compared to unfavorable. So there are 2 that are A. No, take that back. 3 that are favorable, and there are 1, 2, 3, 4, 5 that are not favorable. So the odds are 3 to 5 in favor of spinning an A. The odds against spinning an A would be 5 to 3. The table shows the number of college students who prefer a given pizza topping. Find the probability that a selected student prefers cheese topping or is a junior. So cheese topping would be adding up these numbers, or is a junior would also include these numbers. You don't want to add the 22 because then you would add those people twice. Okay, so cheese or junior So favorable would be adding 10 plus 16 plus 22 plus 23 plus 16 plus 19, which is 106, compared to the total of all of these numbers. So adding up all of the numbers in the entire table, you get 207. So the probability is 106 over 207. Next question. A family has 3 children. What's the probability that 2 of the children are boys? If I draw out a tree diagram of this situation, I could have boy and girl, and the next would be boy or girl, and the next boy or girl. So filling out the rest, boy or girl, boy or girl, so there's all 8 possibilities. Now how many paths would be 2 children that are boys? You could have boy, boy, girl, that's one path. You could have boy, girl, boy as a second path. You could have girl, boy, boy as a third path. So that would be altogether, there'd be 3 out of 8. Probability of having 2 children are boys. Find the conditional probability. If a single fair die is rolled, find the probability that a number rolled is 5, given that it's odd. So find the probability that's 5, given that it's odd. So we know for sure that it's odd. So the only ways to roll a die and get an odd number is a 1, a 3, or a 5, because you cannot roll a 2, 4, or 6, since those are even. So the probability of also rolling a 5 is 1 out of 3. In a 2-card hand, what's the probability of holding 2 kings? Well, there's 4 kings in the deck, so 4 out of 52. And then the second card would have to be a king, so then there'd be 3 kings out of 51 cards. Multiplying that together, that's 1 out of 221. Suppose one card is selected at random from an ordinary deck of 52 playing cards. Let event A be is that, let me try that again. Event A says that you select a queen. Event B says that you pick a diamond. Determine the probability that you pick a diamond given that you pick a queen. Okay, so given that you pick a queen, well, there's 4 queens, so there's a queen of hearts, queen of clubs, queen of diamonds, and queen of spades. So given that you pick a queen, what's the probability that you pick a diamond? Well, that would be 1 out of 4 possibilities. Next question. For n repeated independent trials with constant probability of success p for all trials, find the probability of exactly x successes. So these are Bernoulli trials, and the formula is where q represents the probability of the event not happening. So if p is 1/2 or 50%, then the probability of the event not happening would also be 1/2. Okay, so filling things in, this would be 17 choose 7 times 1/2 raised to the x to the 7 times 1/2 raised to the n minus x, so that's 17 minus 7, which is 10. So calculating this out, 7 choose 7 is 19,448, and that'll be multiplied by 1/2 to the 7 times 1/2 to the 10, so that's 1/2 to the 17th power, which equals 0.148, so that rounds to 0.15 approximately. That's the probability of this event happening. Okay, moving on to statistics. Next problem. Use the graph to answer the question. Which month in year 2 had the highest sales? So the highest sales in thousands of dollars in year 2, the highest would be month 12. Question 31 says, what were the total sales of the first 6 months of year 1? So that would be 48 plus, here that's about halfway, so that's 50. Then we're going to add 44 plus halfway, so that's 46. And then 52 and 50. So there's the first 6 months. So if we add up those, that's 290, and this is in thousands. So that's the total sales for the first 6 months. So the answer was 290,000. Okay, next, we're finding the mean of the set of the data. Okay, so we want to add up the numbers and divide by the number of numbers. So x bar would equal, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. And then adding up, that's 112, and 112 divided by 8 is 14. So the mean is 14. Find the median. For the median, I would need my numbers in order, and they are, okay, so the median is going to happen exactly halfway, but since I have an even number, I need to average the 25 and 26, so that'll be 25.5. That's that median. Find the range. The range is the max minus the min. So the max is 18, the min is 1. So the range is 18 minus 1, which is 17. Find the standard deviation. Okay, I'm going to use my calculator to get this one. Okay, making sure to clear my list. Then I typed in my numbers. If you're using a red calculator, the frequency would always be 1. If you're using a TI-84, then you would press the stat button to clear list L1, type in your numbers, and then calculate for one variable, and I get my standard deviation. It's labeled as SX on the calculator. That would be 6.33, about. Okay, Martin scored 41 points on a quiz. The average was 39 with a standard deviation of 2.4. So we're going to compare Martin with his brother Jeff. Jeff scored a 29, but his average class was 26 with a standard deviation of 1.9. So let's see who does better. Martin, Z is calculated as x minus x bar over s. So Martin his score was 41 minus 39 over 2.4. So his Z score is 0.83. And then Martin's brother Jeff got 29, but the average was 26 with a standard deviation of 1.9. So calculating out that'll be 3 divided by 1.9, which is 1.58. So relatively speaking, Jeff had a higher Z-score, which means that he did better on the standard normal curve and relatively did better than his brother Martin. Next question, find the percent of the area under the curve between the mean and 2.41 standard deviations from the mean. In other words, if Z equals 2.41, then we're finding the area from the mean to 2.41. We're looking for that amount of area. So calculating, using a table to get that. So for a Z-score of 2.41, the area is 0.4920 from the table. The next part, find the percent of the total area under the curve between Z. Z equals negative 2.49 to Z equals 1.19. So drawing a picture of this, here's my normal curve. And then negative 2.49 is going to be over here. And 1.19 is over here. So we need to get each of these areas separately by looking up positive 2.49 on the table and 1.19 on the table. So doing that, we'll get that this area here is 0.4936. This area here is 0.3830. And then because those areas are on different sides of the mean of 0, we'll add them together and get a total area of 0.8766. That's the total area under the standard normal curve between Z equals negative 2.49 and 1.19. Next question. A company installs 5,000 light bulbs. The lifetimes of light bulbs are approximately normally distributed with a mean of 500 hours and a standard deviation of 100 hours. Find the approximate number of bulbs that could be expected to last between 500 and 675 hours. Well, 500 is the mean. So that Z value would be 500 minus 500 over the standard deviation of 100, so that's 0. But then the second value, 675, that z value would be 675 minus 500 over a standard deviation of 100. So that's 275 divided by 100, which is 2.75. So we want the area under the standard normal curve between 0 and 2.75. So we just have to look up 2.75 on our table to figure out that area. Okay, so we're finding the area from a z value of 2.75. So looking up 2.75 on our table, we'll get 0.4970. So that means as a percent, that's 49.7% chance of getting a light bulb that would be expected to last between 500 and 675 hours. Next question. The weekly salaries of 16 government workers are listed below. Find the 36th percentile. Okay, so we're going to find 36% of the number of workers. So they're in groups of 4, so 4, 8, 12, 16. So 30.36 times 16 is going to equal 5.76. But then taking that to the nearest, to the next whole number, that'll be the 6th number in the list. And the 6th number in the list is 619. So $619 for the weekly salary would be the 36th percentile. Problem 41. The math department is holding an election for a department chair. Each member rates the candidates from first to third. The voter profile below shows the results of the ballots with candidates Clark C., Jones J., and Smith S. Okay, so it had this ranking, and we want to determine the winner using the Borda count method. In fact, let's do this with all of the methods. So we're going to do it with the plurality method, the pairwise comparison, the Borda, and the Hare method for this problem. Okay, so first doing it with the plurality. For the plurality, we're only looking at the first place votes. So then for plurality, then J would get a total of 11, whereas S would get a total of 10, and C would get a total of 8. So J would win. That's the plurality method. Then for the pairwise comparison method, we'll compare the J versus the S, the J versus the C, and the S versus the C. All comparisons. So comparing the J versus the S, then J would get 7, S would get 10, J would get 4, and S would get 8. So S wins the first. Then J versus C, J would get 7, J would get 10, J would get 4, and C would get 8. So J wins the second. And then the last one, S versus C. S would get 7, S would get 10, C would get 4, and C would get 8. So S wins. So overall, S wins 2 of the 3 points. So S wins the contest using the pairwise comparison. Doing the Borda method for each. So we're going to compare the J, the S, and the C. So for this then, because we have 3 contestants, then a first place is worth 2 points, a second place is worth 1 point, and a third place is worth 0 points. So J got 7 first place, so doubled. J got 10 second place. J got 4 first place, so doubled. And third place for the last. So altogether, J got 14 plus 10 plus 8, which is 32. Compared with S got 7 second place, 10 first place, so doubled to 20. Last place, and then 8. So S got a total of 35 and is winning so far. Now checking C, C got last place for the first 2 rounds, and then second place, those are 2 zeros, and then 8 first place, so doubled to 16, so C got a total of 20. So S wins the Borda. So for the Borda method, S wins. Finally, for the hair method, we just look at the plurality, and we see that J had 11, S had 10, and C had 8. So the question is, did J wins, but did it have a majority? So if we count up 21, 29, it only had 11 of the 29, so it did not have a majority. That means we're going to eliminate the C's, because that was the lowest. Oops, eliminate the C. So recalculating now between J and S, J has 7, S gets 10, J gets 4, and S gets 8. So S wins the hair. So overall, we see that J wins the plurality, but S wins the other 3 methods. Okay? Given the following voter profile, determine who has the majority of first place votes, and then use the Borda method to determine the outcome. Does the Borda method violate the majority criterion for the voter profile? Well, let's see. Okay, so I'm going to first actually calculate out A, B, and C using the Borda method. So for A, looks like first place votes are worth 2, second place votes are worth 1, third place 0. So A gets 7 doubled, 10 second place, 12 doubled, and third place, so 0. So A gets a total of 24 plus 10 is 34, 48. B, let's count up B's votes. B gets 7, then 10 first place, so doubled, 0, and 8 second place. So that counts up to 35. And C gets a total of 0 for the first 2 rounds, 12, and 8 first place votes, which doubles to 16. So they get a total of 28. So overall in the Borda method, A wins. Now let's, what about with the plurality? With the plurality, we had A having 19, B having 10, and C having 8. So this is out of a total of 37. So that means that A had a majority. So in this case, A does not violate the majority criterion of fairness. Okay, good luck on the exam.